All right, guys, good afternoon. So, today we are going to be talking about our last type of probability in this unit. So, just to recap what we've talked about so far, we talked about simple probability, which is your basic, look at a situation and write a fraction that you learned in elementary and middle school. We talked about compound probability, which is where you took two fractions or two decimals, and then you either added them or multiplied them together, depending on if the question said or and. And then the last type of probability we've talked about so far was conditional. And the conditional probability was the one that had the word given, or it could have had a line in it, okay? But what it did was it gave you a rule that you had to follow. So it said, what's the probability of drawing a jack given that it's a red card? So then you were only allowed to look at the red cards. This last type of probability is called binomial probability, and we only use it in specific circumstances. And I've got those circumstances listed for you. The first thing that has to happen in order for me to use this new binomial probability formula is you have to be performing the same action over and over again, and we call that action a trial. So, an example of a trial could be that you're drawing a card out of a deck. It could be that you're rolling a dice. It could be that you're flipping a coin, but something that you can do over and over again. The next thing that has to happen is that the trials have to be independent, which means what you do one time doesn't affect what happens the next time. So, for example, tossing a coin is a really good example of being independent, because if I get tails the first time I flip it, that doesn't make it any more likely that I'm going to get tails the second time. Okay, they're completely independent what I do from one time to the next. And the last thing that has to happen is there can only be two outcomes of our trial, and we call those outcomes success or failure. So, for example, let's say that you're playing a card game and you have to have the ace of spades to win. Well, then when you start drawing cards out of a deck, we would consider getting an ace of spades a success, but anything else would be a failure because nothing else is going to win the game for you. Okay? If you're rolling a dice and say you need a three to win, then rolling a three would be considered a success. Rolling anything else would be considered a failure. So we're kind of simplifying it down to where we've got two outcomes. Now, in those situations, here's my formula right here. And just to tell you what some of those letters mean, P is the probability of success, Q is the probability of failure, N is the total number of trials, X is the number of successes out of those trials. So, for example, here with N and X, say you draw 5 cards and you want them all to be red, but you only get 3 red ones, then N would have been 5 and X would have been 3. Okay? Now, that formula looks a little complicated. It makes a lot more sense when you actually do an example with it. So for example 1, it says find the probability of obtaining exactly 3 heads in 5 tosses of a fair coin. So let's break this down, okay? First thing, let's figure out what P and Q, N and X are, okay? So P is our probability of success. Well, in this case, we want heads. So getting heads is our success. So what's the probability of getting heads when I flip a coin? Well, it's 0.5 or 1/2. Okay? Q is our probability of failure. Well, what would we consider failure in this case? Getting tails. So what's the probability of getting tails? In this case, it also happens to be 0.5. Okay? Now let's talk about N and X. N is the total number of trials. So N here, if we're flipping the coin 5 total times, then N is going to be 5. And how many heads do we want? Because that's our X. Well, we want 3. So out of these 5 tosses, we want to get 3 heads. Okay? So here's the thing. You can go through and plug these directly into the formula. I want to explain to you what's happening here, and we'll take it piece by piece. So there's 3 pieces in this formula, and the first one says NCX. So I'm going to go ahead and fill in the N and the X with 5 and 3. Okay? So there's a C. And it may not let me put a little 5 there. We'll see. Hopefully it will. Well, that's supposed to be a little 5, but you get the picture. Okay, so 5C3. We talked about this at the very, very beginning of the year, but we said NCR instead of NCX. It's actually a button on your calculator. But what it's doing is it's calculating all the different ways that you could get 3 heads out of 5 coin tosses. It's going to count up how many different ways you could do that. So, for example, you could flip tails, tails, and then heads, heads, heads. You could do heads, 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 tails, tails. You could do tails, heads, tails, heads, tails. Okay? Or excuse me, you would have wanted 3 heads there, but either way. But it's counting up all the different ways that you could get 3 heads if you were to flip a coin 5 times. Okay, then we move to the second piece. The second piece says p to the x. Well, what's p? P is 0.5. And what's x? X is 3. So think about what that means. What you're saying here, the probability of success is 0.5. You want to have 3 successes right here. So you're saying, think about what you're saying. You want a heads, and then another heads, and then another heads. Well, when we say and in a problem, we multiply. So it's the same thing as doing 0.5 times 0.5 times 0.5. So this part right here represents the probability of me getting 3 heads in a row. Okay, then I go to the last part. It says q to the n minus x. Okay, and let me explain to you what that is. So q is our probability of failure. So this last part is going to deal with getting tails. So what's happening here is I'm saying, well, if I got heads 3 times out of the 5, then I want to get tails 2 times out of the 5. So that would be 0.5 squared. Okay, and watch how I type this into Desmos. So I do NCR 5, 3, okay, and I get 10. And then let me find my little multiplication symbol, wherever it may be. Oh, there it is. Times, okay, 0.5 to the third, times 0.5 squared. So right there, my probability if I flip a coin 5 times of getting heads 3 times is 0.3125. And then you're done. Let's take a look at example 2. Find the probability of obtaining exactly 2 5s in 7 rolls of a fair die. Okay, so let's take it piece by piece. That first part was NCX. So we have 7 total rolls. Out of those rolls, we want to get 5 2 times. So 5 is considered our success here. So the first thing that I type is 7C and then 2. Because out of 7 total rolls, I want 2 successes. Okay, then if I look back at my formula, the next part is p to the x. Okay, p is my probability of success. Well, getting a 5 is considered a success. So what's the probability of rolling a 5? Well, that's 1 out of 6 on a dice. And how many times do I want to roll a 5? Well, I want to roll it twice. Okay, so that took care of my probability of success. The last part of my formula here deals with the probability of failure. So getting anything other than a 5 is considered a failure. So what's the probability of getting anything other than a 5? Well, it's 5 out of 6. How many times do I want to get something other than a 5? Well, if I'm rolling 7 times and I want 2 of them to be 5s, that means I want 5 of them to not be 5s. And then I go over to Desmos and I type it in. So I do NCR 7, 2 times 1/6 squared. Oh, okay, times 5/6 to the 5th. And it tells me my probability there is 0.2344. All right, very last example, example 3. You draw a card from a deck 10 times in a row, replacing the card each time. And I want to remind you of why that's important. Okay, remember that one of our conditions for binomial probability is that the trials are independent, meaning that what you do the first time doesn't impact what happens the second time. Well, if you don't put those cards back in the deck, you now have less cards to draw from every time, so your probability of getting different cards gets higher and higher every time. Okay? So let's take this step by step. You draw a card from a deck 10 times in a row. So N is 10. That's our total number of times that we're drawing. Okay? What is the probability of drawing a spade exactly 4 times? So, how many successes do we actually want out of those 10? We want 4. So X is 4. Now let's go back and talk about P and Q. What is our success and what is failure? Success is drawing a spade. So what's the probability of drawing a spade? Well, spades make up a quarter of the deck. So the probability of success here is 0.25. That means our probability of failure of drawing anything that's not a spade is 0.75. Okay? So now let's look at our formula and take it piece by piece. So that first piece, that NCR, is just going to tell us how many different possible ways we could draw 10 cards and have 4 of them be spades. Okay? So maybe you got 6 hearts and then you got 4 spades. Maybe you got 3 diamonds, 3 hearts, and 4 spades. So it's going to count up all the different ways that could happen. So we'll do 10, C, 4. Okay? There's the first piece. The second piece of our formula is that P to the X, so that's our probability of success. Well, what's the probability of success of actually drawing a spade? It's 0.25, and I want that to happen 4 times. So I raise it to the 4th power. Then that last component deals with the probability of failure. What's the probability of not drawing a spade? Well, it's 0.75. And how many cards do I not want to be spades? Well, if 4 of them are spades, that means 6 of them won't be spades. And Desmos will help me calculate this again. So NCR, okay, 10, 4 times 0.25 to the 4th times 0.75 to the 6th. And right there, my probability in getting 4 spades out of 10 cards is 0.146. And then you're done. Okay, so guys, that is binomial probability in a nutshell. I will post these notes in the assignment for you to look at, but please let me know if you have questions.